Hi guys. So I wanted to talk to you about special cases when we are solving algebraically. We've already talked about special cases when we're solving by graphing, but we need to be able to know which special case applies when we're solving using algebra. So we'll be taking a look at both special cases as well as both ways of solving algebraically. Here is our first example. For our first example, I would like to practice substitution, which is what we learned on Monday and Tuesday of this week. Now, this problem is not currently set up for substitution, so we will need to do a little bit of rearranging. Given the choice, I am going to choose to solve for x in the first equation, since it's the only variable that does not have a coefficient. To solve for x, all I have to do is minus the 2y. Now that I have solved for x, I will be taking 4 minus 2y, and I will be substituting it into the other equation where the letter x is. So again, make sure that you're never substituting it back into the equation that you got it from. Always substitute it into the other equation. Also remember, it's good to substitute using parentheses so that you remember to distribute. That's going to be my next step right now. I'm going to distribute the 3.5 to the 4 and the minus 2y. Next, I like to combine like terms. So I have these two terms with the letter y here. So I will be combining those together. Now, unfortunately, in this problem, I have a negative 7y and a positive 7y, and that makes 0 letter y's. Those are going to cancel out, leaving me without any more variables in this problem. What I have left over is the equation 14 equals 14. When you're solving by substitution, and all of your variables cancel out, and you're left with two numbers. Those are not the answers. You need to ask yourself, is this a true statement? Does 14 equal 14? And the answer is yes, it is true. Now, in a system of equations, when we get a true statement with all of the variables canceled out, our final answer is the special case, infinitely many. Now, we talked about on our graphing special cases why it is infinitely many and not all real numbers. All real numbers is not an acceptable answer this chapter. The reason why is that we are figuring out where two lines are intersecting. And in this scenario, when we were graphing, it was the one where we drew a line and then we drew another line directly on top of it. So those two lines are touching in an infinite amount of spots, but they're not touching everywhere on the coordinate plane. So we can't write all real numbers because that means everywhere on the whole coordinate plane. Instead, we write infinitely many because they are touching in an infinite amount of spots on a straight line. So infinitely many when you have all of your variables cancel out and you have a true statement. That's special case number one. This can happen on substitution or elimination. So I showed you an example with substitution, but this could also happen in elimination. And I'm going to use elimination for my next example. So here's our next example, and we're going to practice elimination with this one. To do elimination, I need one of my variables to have the same coefficient, but different signs. And so in this problem, it's equally easy to eliminate your x or your y. I'm going to just focus on the x because it's written first. No special reason why. And so looking at my x's, I have a 3 and a 6. And I can very easily change a 3 into a 6. All I have to do is times it by 2. But I want it to be a negative 6 because a positive 6 and a negative 6 would cancel. So I'm not going to times by 2. I'm going to times by negative 2. Don't forget on elimination to distribute your negative 2 to all three terms. So it'll turn into a negative 6x, a negative 8y, and a negative 20. So make sure to distribute to everything. In this example, I don't need to multiply the second equation, so I'm just going to stack it underneath. Now, when you get a special case in elimination, what will end up happening is instead of eliminating one variable, you're actually going to eliminate both variables. Now, don't stop here. You have to keep going. So when everything cancels out of the left-hand side and you have nothing left over, the number that signifies that you have nothing is 0. So we are going to need to write the number 0 on the left-hand side. On the right-hand side, we still have some numbers, so we would still do that math. -20 plus 5 is -15. So now I get a new equation without any letters. All the letters have canceled out, and it says 0 equals -15. You do need to write that step. That is mandatory, because we're going to look at that step and we're going to ask ourselves, is this true? If it is true, just like on that previous example, you would write infinitely many. This statement is not true. It's false. When you get a false statement, then you write no solution. And remember from our graphing video that no solution means that we have parallel lines. Okay, so these would be parallel lines. So this is what the special cases look like. We have two, infinitely many, or no solution. They can happen in any way of solving. They can happen with substitution, elimination, or graphing. So just be on the lookout for those special cases. And this is the end of our special cases video.